Let's apply these principles to a histogram or a smoothed over curve that we know as the normal curve. So for instance, can we see how probabilities and proportions go hand in hand here? If I were to ask, for instance, what proportion or what probability of values are less than 4.5, with using the upper real limit of 4.5 here, you can see that, well, geez, it's 8 out of 10, and only 2 out of 10 are above 4.5. So I can dissect it in that way fairly easily. I mean, that's no problem at all. That's fairly easy to do. By the way, your text doesn't acknowledge real limits there, but I think we should, so that's why I peppered in 4.5. So if I move on from that, well, let's take the entire normal distribution. May we do the same as we did right before the break with the normal distribution? And of course, yes, we need those unit normal tables or Z tables. And you can see here, and again, this is from your text, these particular Z scores of 1 or 1.5 or negative 1/2, and we're looking for the proportion that's shaded in. So I want to know what proportion of the normal curve is greater than 1, a Z of 1. Less than 1.5 or less than negative 0.5. Well, as you can see, here's a sample of our Z table. Now, what should be noted is that the body and the tail always add to 1, and then you have the proportion between that value and a Z of 0, which is between the mean and Z. Each of these columns will have their own utility later as we're solving these problems. But now that we've been through this a good number of times, and of course you have access to the Z tables that I've scanned in on D2L, we're pretty darn familiar with this. Our tables are very friendly. Sometimes textbooks only have 2 of these 3 columns and let you sort of do the math on the missing one. So for instance, I've seen tables with only B and D before, and you have to sort of do the math on C. But we've got everything we need, and it's a very, very friendly table. So let's say, okay, let's take letter A here. The proportion of Z scores greater than 1. Now, what I have to do here is plant my flag first. Let's go to a Z of 1 and then ask the question, are we going to the right or to the left? Well, if it wants us to go to the right, as the orange shading suggests, well, in that case, that's where we'll go, and we're already starting to the right with a Z of 1. So, of course, I go to my Z tables as I've scanned in here, and that's definitely going to be the tail value. It's the smaller portion. The smaller portion is the tail, and, of course, the answer would be 1587. Now, scanning over to B, we're starting with a Z of 1.5, and it wants to go to the left, the proportion of Z scores that are less than 1.5. So I plant my flag first, if you will, figure out where the Z score is, and then decide if I'm going left or right. I follow the arrow. Well, if I plant the flag on the right and then I'm going left, well, that's a majority. And sure enough, that proportion is 9332. A huge majority of the curve, 93 and about 1/3%. And then finally for the last one, if I'm starting with a negative Z score of negative 0.50 and then going left, as I can see visually, that's clearly a tail. No question about it. And in that case, that's going to be the tail value of 0.3085. So the trick is plant your flag first. Get that flag down first, and then decide which direction you're going on. So if somebody came from another planet and said, hey, if I said to this person from another planet, would you like to go on a bus trip from Newark, New Jersey, all the way to the Pacific Ocean? Well, they wouldn't know what to say because they don't know what a daunting trip that is. You're going all the way across the country. They might be able to plant the flag, if you will, but they don't know what direction, etc. In our case, we have to sort of think of it that way. I plant my flag first and then decide how far I have to go, left or right, if it's clearly a body or a tail. Now, here's one that we really didn't get to in class, but it's from your textbook. If I want to know what Z scores at the 90th percentile, well, I have to look at the tables. Now, what I'm trying to do is get as close as I can to 10% in the tail, and 1.28 will do that. Now, by the way, I know it's a positive value of Z because it falls on the right. I know that 90th percentile, where I'm closing off 90% to the left and 10% to the right. 90% to the left and 10% to the right. I know that's got to be on the right side because when we're talking percentiles, we always go to the left. I may have said 10th percentile before, excuse me. But definitely the 90th. That's what this is calling for. That 90% of the curve is to the left. And in that case, the best I can do to separate off 90 and 10 from the tables is this value of 1.28, which I know has to be positive because it's on the right. It has to be. And we don't have to get any closer than this. We don't have to use interpolation. Then the other one is, and this is a bit trickier, what z-scores isolate 60% in the middle? Well, if I had 60% in the middle, 0.60000, wouldn't it be roughly 20% in each tail, totaling to 100? Well, of course. Is there a z-score that'll do that? Yes. The closest we could get is a z of 0.84 or negative 0.84, because they leave roughly 0.2000 in each tail. And then, of course, they're going to leave a total of 0.6000 in the middle. And in that case, that's as close as we can get. Again, I don't have to engage in any interpolation at all, which is nice. I appreciate that. That's interpolation is kind of... let me tell you a story if you don't mind. For those of you that have Math 220, they actually do engage in some sort of interpolation. But we don't do that here. I think it would just frankly eat too much time. We don't have to be that exact with what we're doing. But nonetheless, we're just winging it with our tables, just getting as close as possible, which I think is a good balance.